ratio of R to S equals 3 to 4. The ratio of S to T is 2 to 9. R to T equals question mark. Okay, so to make things a little simpler here, I'm going to get rid of the fractional parts. So multiply both sides here by 4. 4R equals, and then also by S, 3S. Then we have here, I do the same thing. I'll end up with 9S equals 2T. Okay, so now I have a 3S and a 9S. If I multiply both sides of this by 3, I'm going to get 9S, which I can then set equal. So we're going to do that. 3 times 4 is 12R equals 3 times 3 is 9S, which equals this, equals 2T. Okay, so now what I want is R to T. So I have R here, and I want to bring T below. So I'm going to divide both sides by T to get rid of that, and I'm going to divide both sides by 12 to do that. So R to T equals 1 to 6. Alright, we have a straight line with points A, B, C, and D. B, C, and D. CD is 6. CD is greater than BC, so this value here needs to be something a little bit less than that. So we'll call that X, and then AB has to be a little bit less than that. We'll call it Y. Which of the following could be the length of AD? Alright, so 6 here is going to be the upper bound on these other two values. So X here could be 5.999, and it's still less than 6. And this one here could be 5.998. Alright, so to approximate that, we have approximately 18, just a little bit less than 18 is the maximum value that this could be. It could be, these could be 0, right, which would make it 6. Actually, it could be negative as well. So all of these numbers here are 18 or bigger. It can't be 18 because that would require X and Y to be equal to this guy, but they're less, which means that we have to have 17. The table above gives values of the linear function f for selected values of x. Which of the following functions defines f? The way I like to approach these is I kind of look at the difference here, it's 1, difference here is 1, difference here is 1, difference here is 2, 2, 2, which really means that for every time that x changes by 1, f of x changes by twice that. So we have to have a 2x in there somewhere. Right? So we already know that this here has got to be the answer because it's the only one with the 2x. To take it a little bit further, if you were to take 2 times 4 is 8, that's the 2x, you wouldn't quite have 10, you have to actually add 2 to make it all work out, which actually happens to be this value here. That's a plus behind the squiggle that I made there. So C is the answer. In the figure above, line L and N are parallel. Which of the following are not necessarily equal to E? Alright, well, let's start by seeing which ones are equal to E. We have H, because these are parallel. A, D is opposite of A, so it's going to be equal. Alright, so which ones of these are not equal to E? Well, A is equal to E, so that one's out. H plus D divided by 2, H plus D divided by 2. H is equal to E. D is equal to E. Right, so we have 2E divided by 2 equals E, so that one's out because again we're looking for not equal. A plus D divided by 2. A is equal to E, so is D. Same situation as before. that one's out. So then f plus h divided by 2. F and h are opposite of each other on a straight line, so that means that we have 180 divided by 2 is 90. So E doesn't have to be equal to 90 because they didn't tell you that these are parallel. So it means that this one here is not necessarily equal to E, which makes this the answer. Alright, if k is a positive integer, which of the following is equivalent to 2k to the 1/2 all to the minus 2 power? Okay, well, let's get rid of the parentheses here. We multiply this minus 2 power by everything inside, which you can only do if there's not a plus sign inside of here. So we're going to have, so like if you had 1 plus x to the 2 minus 2 power, you can't just distribute, and make it be 1 plus x to the minus 2. No, you can't do that. But here, there's no plus. There's no order of operations issue. So 2 to the minus 2 times k to the 1/2 to the 2, which we can multiply. So here, minus 2 actually means 1 over 2 squared. Right? The minus 2 brings it down here. So we have 1 over 4 times k to the 1/2 times 2. You really just multiply these two, so you have k. 1/2 times 2 just makes 1. So, oh, and we still have a minus here, so we have to do 1 over. So 1 over 4k. Alright, t is 40% greater, which means 1 plus 0.4, because you have the original amount plus whatever, right, greater. So they're not saying 40% of, which is just 0.4, they want greater, so you have 1 plus that. Then p, and p is 40% less, so we're going to have 1 minus 0.4, 600. Okay, so this here is going to be 0.6 times 600. Right, 0.6 times 600 is 360. Okay, so we know what p is. So now t is going to be 1 plus 0.4, so 1.4 times 360. Coming back to our trusty calculator, 1.4 times 360 equals 504, which is this answer right here. In the sequence above, each term after the second can be found by multiplying the two preceding terms. For example, the third is the minus 2 times the 4. They forgot a minus here, looks like. Alright, so the first is going to be minus 2. Then the next is going to be 4. And then the next is going to be 8. And then minus 8 times 4 is going to be minus 32, and so on. How many of the first 139 terms of the sequence are negative? Alright, let's see here. Let's continue this on. This is going to be some number, but it's going to be positive. Okay, then the next one is going to be negative, negative, and then because we have two negatives, it's going to be positive again. So we end up with minus, plus, minus, minus, plus, minus, minus, plus, and then the pattern repeats. Alright, so they want to know how many of the first 139 are negative. Okay, so it looks like after the first two, we have a repeating pattern. So what we want to do is take 139 minus 2 is 137. So we have one negative here plus however many negatives are in the remaining sets here. So if we take 137 divided by 3, 137 divided by 3, it's going to be 45.66, which is 45 2/3. Okay, so here we have 45 2/3 sets. Okay, so in 45 of those sets, we're going to have two negatives each. Right, so we want times 2, which 45 and 45 is 90. And then we have 2/3 of a set after that. Now the first two are negative, so that means that we're going to get plus 2 more negatives. So we have our first negative here, plus 91, 90 is 91, plus 2 is going to be 93, which gives us this answer here. In the figure above, the value of h of 5 is going to be k. Okay, so that means, and here h of 5 they tell you is the formula for the line as you go along the x. Okay, so really it could just be written as y of x, but whatever. So 1, 2, 3, 4, 5, so we're talking about this point here. Okay, 1, 2, 3, 4, 5. Okay, so we know that h of 5 equals k equals 5. Okay, then they want h of 2k, which really means h of 10, right, because we have 2 times 5. So really we just need to look on the number line for number 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10 is this guy, which that is 7. A bag of marbles, 2/5 of them are red, 3/5 of them are white, and 1/10. Did I say? In a bag of marbles, 2/5 of them are red, 3/10 are white, 1/10 is blue. The remaining 10 marbles are green. How many marbles are in the bag? Okay, so we know that we have 2/5 of the total plus 3/10 of the total plus 1/10 of the total plus whatever is the remaining proportion is all going to be the total here. So plus some number of green is going to be equal to t. Okay. All right. So simple algebra. So let's combine these here with fractions. So we need to convert this guy here to tenths. So we're going to have 4 tenths. So 4 plus 3 is 7, plus 1 is 8. Tenths t plus the number of green, which happens to be 10. Okay, so actually we can just put a 10 here, equals t. So bring t by t together. So we have t minus 8/10 t equals 10, because really I just subtracted both sides here and kind of moved things around. But so here this is going to be 10/10 t, so 10 minus 8 is 2/10 t equals 10. Okay, so multiply both sides by 10, get 100 here, divide by 2 to get 50, which makes this here the answer. If x and y are positive numbers greater than 1, then and wx equals y plus w equals 1, if wx over y plus w equals 1, then w equals, well, really they're just asking to isolate w by itself. So if we have wx divided by y plus w equals 1, well, I usually like to get rid of the denominator, so if we multiply both sides by y plus w equals 1 here times anything is just whatever the anything is, plus equals y plus that. So now we're going to put the w's together. So we have wx minus w equals y. Okay, take out the w, so we have w of x minus 1, okay, equals y, which means that w equals y divided by x minus 1, making this here the answer. In the quadrilateral above, ON, call it A, equals OM, so this one's also A, equals OP, also A, MN equals MP, these two here are equal, so it's A. So really what we have is either a diamond or we can have a squished diamond with lines going through it. Okay, what's the value of x here? Well, since here everything has to be symmetric, these lines here are all equal. So that implies that, and since this here is because of that, this has to be 55, and actually this here also has to be 55. So then if we do, we look at this one here, x plus 90 plus 55 equals 180. Okay, 90 plus 55 is 145. So 180 minus 145 is going to be 145. So that's a 7, so 35, which makes this the answer. From Wilton to Norwalk, there are 5 roads. From Norwalk to Darien, there are 4. So if Christina drives from Wilton to Darien and back, but doesn't travel any road twice, then how many possible routes are there? Well, on her way out, she has 5 choices. Then from here to here, from Norwalk to Darien, she has 4 choices. Returning, she's used up one of those choices, which means she has 3 choices. And then here returning, she has 4. So multiply all those together. So 5 times 4 is 20. 3 times 4 is 12. 20 times 12 is going to be 24, 0. Here I do the 2 times the 12 is 24, plus we have a 0, which is 240.